So you have to recall that in our last class, we did talk about the concept of two different formula that can actually be used to find the sum of a geometric progression. And we went further to looking into a case where the first one actually fitted into what we wanted to do. So today, we want to look at an example that will reflect on the second one, and of which we can even go further to see that it actually works on the set example. So let's see. How about we're asked to find the sum of the first four terms of the GP. What is the GP? 8, 4, 2, and 1. We were asked to find this. So very normally we have to bring out our parameters. So our A here in this case, A is given as, can clearly be seen to be 8. And now about N, we're asked to find the first four terms. So N in this case is actually 4. And what's our R? R can be given as 4 divided by 8. So let's say 4 divided by 8, and that's 1 over 2. 4 cancels itself 1 and goes into 8. It is 2 times. So to that end, we can see the formula that suits this. It is actually the second one, because R, 1 over 2 means a half, and that's clearly less than 1. So let's go ahead to fix it into this. So we can say sum of the first four terms, A is 8. And we open our bracket, this 1 minus R. Our R in this case is 1 over 2. 1 over 2 raised to the power of N, and N in this case is 4. All over R again. Our 1 minus R is 1 over 2. So we close our bracket, and we can actually continue from there. So we have to pick each of these and treat it, pick this, and then we move ahead. So let's see, what is 1 all over 2? Let's pick this and treat it. 1 over 2, 1 over 2 to the power of 4 means the numerator 1 raised to the power of 4 all over the denominator 2 raised to the power of 4. And that's 1 to the power of 4 means 1, and 2 to the power of 4 means 2 times 2 times 2 times 2, and that will give us 16. So for the numerator, we can now say it means 1 minus, in place of this, I'll drop 1 over 16. And how about, since this is a fraction, I can as well give this over 1. So the LCM of 16 and 1 will be given as 16. Now, 16 divided by 1 is 16 times 1. So that's 16 minus 16 divided by 16 is 1. 1 times 1 gives us 1. So we see our answer is 15 over 16. Over 16. This will take care of the numerator, so we keep it there. Then we also consider, let's consider solving the denominator. The denominator, let's see what's there. 1 over 1 minus half. So we can as well give this over 1. So the LCM of 1 and 2 can be given as 2. So that we say 2 divided by 1 is 2. 2 times 1 gives us 2. Minus 2 divided by 2 is 1, and this gives us 1. So this is 1 over 2. And of course, 1 minus a half is a half, which is 1 over 2. So let's say we are through with the numerator and of course the denominator. So we'll just slot in the values. So to that end, we can easily say that sum of the first four terms is 8 outside. Notice that the whole of the numerator had given us 15 over 16. That is, the whole of this numerator had given us 15 over 16. So we'll just replace that with 15 over 16. And the whole of this denominator is what has given rise to 1 over 2. So we'll just drop 1 all over 2. So what we'll now do is that our S4, sum of the first 4 terms is 8 times 15 over 16. This is the numerator. This is all the numerator. Then the division sign, we can just say divided by 1 all over 2. I hope we are following, which in turn I can write that my sum of the first 4 terms is 8 times 15 over 16. And I'll use what is called multiplying by the reciprocal, where the division sign changes and then we take the reciprocal of the last fraction. So I can change this to multiplied by 2 over 1, which will in turn give us 8 times 2 is 16 times 15 over 16. So that gives us, and our answer is given as 15. So I did promise at the beginning of our solving that at the end of it, we're going to confirm if it's actually a typical case where we can confirm our answer. So now, having gotten our answer as 15, let's confirm if that's true. If we're to add 4, 8 plus 4 is 12, plus this, 14 and 15. It actually worked.